once again. So I will be discussing Gaussian-Jordan elimination or Gaussian elimination method to solve the system of equation in matrix form. And they are in two ways. We have one with back substitution, and we have another one that is we can use a row echelon matrix to solve it. So it all depends on which one are we talking about. But the first thing I will be talking about is the one with using the back substitution method and to get our x, y, z, or any other variables you have been given, or you are asked, or the number of unknown you're asked to solve. So at the end of the day, it leads you to simultaneous equation whereby you find after reducing it. And the major things I want you to note this morning is when you are reducing it, what are the things you need to take note? The first thing is your diagonal element or must be equals to identity, it must be equals to 1. And while the lower part of the triangle, all the element there must equals to 0. Once you take note of that, it make life easy for you and you'll be able to solve as many problems as possible. So on this note, let me try and share my screen so then we can continue from where we stopped last time. And can you see my screen, please? If you can see my screen, please.
Yes, sir. You can see your screen, sir.
Thank you.
Yes, sir, we can see.
Okay, now, like I said, I'm not going to, if you check your textbook or your course guide, it is there. Different methods are there, which we'll still try to explore as time goes on. But in this case now, we want to see how to use the use of Gaussian Jordan elimination, or we can call it Gaussian elimination to solve this system. So I'll go straight to the example. I've explained to us that one of the things you need to take notes is, number one, okay, let's look at the example. X plus y minus z is equals to 9. Then y plus 3z is equals to 3. Then minus x minus 2z is equals to 2. So these are the system of equation we want to solve. So from here we can proceed. First thing you need to rewrite, the solution will be or let's just put it this way, write it we write in for matrix form. For matrix form, we have it to be, I've explained to us some times ago. This case now is going to be 3 by 3 matrix because our equation is 3 by is x, y, z. So we have it to be, the first one will be 1 because our S is only 1. Y, nobody will put 1 here, but it's 1. We only have 1 X, 1 Y, 1 Z. So this is 3Z, this is 2Z. So and so on and so forth. Please let's take note of that. And we have another one here, and the Z carry -1. Then you put all your constants also inside the and demarcate it like this. Put 9 here. Then we don't have X in the second equation. We put 0. We have Y, 1. We have Z, 3Z. We only have negative here, -1. Here we don't have Y, 0. We have -2. Then here we have 3 and 2. So the journey begins. So for us to solve this, from the skill we've gathered from the row reduction, we can now solve this one. How do we solve this? Remember, our target is this. Look at this. Look at the targets. Everything here must be 1. They must equal to 1. Then the lower triangle, this is lower triangle, all the elements here must equal to 0. All the elements here must equal to 0. Let me just clean the diagonal. So all the elements here must equal to 0. That is this place. They must equal to 0. That is our target. If you can achieve that, that means you already solved the part 1. Then the part 2 is to now put everything back to the equation. That's why it's called back substitution into the equation, and you get your X, you get your Y, and you get your Z. So on this note now, we have 0 already in first column of row 2. We have 0 in the third column, in the third row and second column. So what you need to do is, let's work on which of the row do you think we need to start from?
Row 3.
Row 3. Okay, let's start from row 3. Why? Because we need to make this young man to be 0. So row 3 will now lead to, who can tell us the operation?
Row 3 is row 3 plus 1, row 2.
Row 1
Row 3 plus row 1.
plus row 3, Abby. Row 3 plus row 1, right? Okay, row 3 plus row 1 is very simple. Let's look at it together. So row 1 will remain its identity. Row 1, 1, -1. It will remain its identity. Row 2 will also remain its identity, because we didn't mention row 2 there. We are only working on row 3 first. Now for row 3, how do we solve the row 3? It's going to be -1 plus 1, because -1 is the element equals to 0. So you put 0 here. So you put 0 there. So the next one is 0 plus 1 is equals to 1. So you put 1 here. The next one is -2 plus -1 is -3. You put -3 here. Then the next one is 2 plus 9 is 11. You put 11 here. So we're done with that. Are we achieve our aim? No. Remember, we need to make this young man also to be 0. So for us to make it 0, who can tell us the operation? Apart, Deborah, don't talk, please. Any other person, please?
Row 3 minus row 2.
Row 3
minus row 2.
Remember, you are working on row 3 again. Look at it critically. I know we are working on row 3. Yes.
Hello, sir.
Yes.
Row 2 minus row 3.
Row 2 minus row 3.
Yes.
No.
So can we go with row 1 minus row 3 again, and row 3 again, as in row 1 minus row 3?
No, it's too far now. You can only work, you can work with the solution lies between 2 and 3.
1, 3.
You said?
You can add them together.
You said what?
Row 2 plus row 3.
Yes, it won't give us. Remember, this one must give us 0.
Okay.
Why can't you look at it? Minus 1 multiplied by row what? The first person that mentioned it got it, but the way he put it, she put it. It's still the same thing. Do you agree with me?
Row 3 minus row 2 will give us.
Row 3 minus row 2 will give us the same thing. That's why I just want her to think again, or any other person to think another method. Is that okay now? So let's continue. So we have our 1, we still remember, remain the same. We have 9. Here we have 0. We have 1. Yes.
I have a question.
Go ahead.
Okay, so I said row 3 tends to minus 1 times row 2 plus row 3. If this happens to be a theory question and one does row 3 minus row 2, will it not be marked right?
You will. You will. That's what I'm saying. It's still more, it's still the same, because if you take the negative, remember commutative, additive, if you take it to the other side, it's still the same.
All right, thank you, sir.
Yeah, you're welcome. The only thing that can make it change, if you put negative here, that's the problem. Okay, let's continue. So it's going to be what? Now, let's look at the operation now. It's going to be minus 1. Minus 1 plus what, please? 0, 0. So the next thing will be minus 3 plus minus 3 equals to what? Minus 6. The next is minus 3 plus 11. That should be 8. So any question? Yes.
I think something is say if we put minus between the.
I'm sorry, I can't hear you. I can't hear you. Yes, Akim.
Sir, where did we start from? How did we get this minus 1? Row 3, your minus 1 bracket row 2 plus row 3. I've gotten lost there. I don't know how we arrived there, sir.
Okay, look at it. From here, we have our mission. Our mission is to make all the elements here to be 0.
All right, sir.
That is our first target.
All right, sir.
And that should be your first target too.
All right.
So that means this must be 0, this must be 0, this must be 0.
All right,
But
sir.
you must make them 0, the 3 elements 0, without using other method that you must be able to justify them.
All right, sir.
Excuse me. The first thing is, let's work on row 3. We work on row 3. We know that row 3 is negative. Minus 1 plus 1 will give me 0. For row 3, I use it.
Yes.
So I do that one for row 3 alone.
Okay.
I got this one. And I still see another one is still here. I need to eliminate this one. How do I eliminate the one? Then I introduce negative here in 2, in row 2, so that in order to make row 3
to be 0,
elimination, in order to eliminate row 3.
Yes. Okay. Yes.
So nobody will tell you. You will be the one to discover it.
Okay.
And other way, you can also write this one to be row 3 leads to the other lady said row 3 minus row 1, row 2 rather.
Row 2.
Remember, it's still like I'm saying row 3 plus negative 1 multiplied by row 2. Because when you open this negative, it will add this one.
Yes.
Is that okay?
Yes, yes.
So somebody also raise up the hand. Who again?
Okay, sir. From the solution, we have a minus 3 plus bracket minus 3, which we got a minus 6. But from the operation here, we have 9. Instead of minus 6, you wrote 3.
Where? Oh, where do I write? Here.
Yes.
No.
But from the solution here, you have
their
minus 6.
own.
Okay.
This is the operation where we are working on row 3. Don't forget.
Okay.
Look at it from here.
Okay.
We are working on row 3. We are just making use of row 2.
Okay.
Is that okay now?
Yes, yes, very okay, sir.
The row that you are working on will be the one that will be changing.
Oh, okay. Okay, sir.
Take note of that. So now we've achieved this side. Now that we achieved this, we can now look at it. Is our diagonal element, we've achieved the lower triangle. You see? They are all 0. Now, look at the middle one. Are they all 1? Okay,
No,
the
sir.
last one, we've not put this one there. The last one will be what?
8, sir. 8.
8. Thank you. So for us to achieve the main purpose here, we need to check what are the things we need here. This particular element must be 1. How do we make all these 1 to be 1? We don't have problem with row 1. We don't have problem with row 2. What about row 3? What do we do? Anybody?
Now say row 3. Row 3 multiply the 1 by minus 6. 1 divided by minus 6. Then it will now make that one to be 1.
Do we all get what the professor is saying now?
Yes, sir.
Okay, he says, look at it. He said R3, which is row 3 that we are going to work on, tends to be Remember, this must be 1. Minus times minus plus minus 1 all over 6 R3. So this is your new R3. I can write it here. Let me just put it here. It's going to be 1, 1, minus 1, 0, 1, 3, then 0, 0. Remember, at this point now, you have minus 1 all over 6 multiplied by minus 6. This one cancel this. Who is that? Mute yourself, please. This one cancel this. You have 1. So you do the same thing to your constants. 9, 3 is going to be minus 8 over 6. What can go? 4 over 3. Negative. You said minus 4 over 3. Any question, please? So that is the part 1 of the problem. So the part 2 will now be, we all know that from our equation, let me write the matrix here again. This is first X, Y, and Z. You all agree? This is 1, 1, minus 1. Here is our constant. Our constant is 9. We have 0, 1, 3. This is 0, 0, 1, and this is 3. And this is minus 4 over 3. So this is what we have. We want to use it. We go back to our equation. Anything you have here for equation 1 will be 1 multiplied by X is X. 1 multiplied by Y, the first row we are dealing with now, plus Y, minus 1 multiplied by Z, minus Z, equals to what? Constant. 9. Any question, please? Silence means no question. 0 multiplied by X, 0. We don't need to write.
0.
Okay, let me write 0 so that you see.
0.
Somebody will still ask you, where do you put the X? 1 multiplied by Y, plus Y. 3 multiplied by Z plus 3Z. Equals to what?
3.
3. 0 multiplied by X, 0.
0.
0.
0.
Then plus Z equals to minus
3.
No, minus 4 over 3. So we need to calculate our X. We know Z. Our Z is equals to minus 4 over 3. Then where can we substitute Z to get our Y?
Equation 2.
Equation 2.
Equation 2 become plus 3Z over 3, over which implies Y plus 3 all over minus 4 over 3 equals to 3. So from there, we can say this cancel this. We have Y minus 4 equals to 3. Take it to the other side, our Y is equals to 7. So we can now substitute Z and Y into equation 1. So equation 1 is X plus Y minus Z equals to 9. Equals to 9. So from there we can substitute it. So this one will be x. What is our y? Plus 7 minus z is minus 4 over 3 equals to 9. You and I know that we can multiply through by 3 in order to cancel this 3. Multiply through by 3. So you have what?
3.
We have 3x
3x plus 21
plus 21 minus and minus
plus
plus 4
4
equals to 27. So we can add this one together by saying 3x
plus 25
plus 25 equals to 27, which implies 3x equals to 27 minus 25. 3s equals to 2.
3.
Our s is equals to 2 over 3. Any question, please? So therefore, our final solution is our s is equals to 2 over 3, y is equals to 7, and that is equals to minus 4 over 3. Any question? I believe it's okay. Can you please mute yourself, madam? Yes. Quadri, you raise up your hand or you forgot yourself? Which one? Any question? Okay, now I will give you this question now, and I want you to solve it. I will only give you 5 minutes to do that. It's for your own good. If you like, solve it. If you like, don't solve it. On the 18th, you will solve it, right? 4x plus y minus z is equals to 12. X plus 3y plus z is equals to 18, and 2x minus y minus 2z is equals to minus 3. So solve for x and y. Is how many minutes do we want?
30 minutes.
For what? It's because I'm explaining. I know some people already started it. So you only have 7 minutes. Learn to be fast, the maximum. So this is 9:49, right? 9:50. So 3 minutes to 10 will stop. Start now. Don't once you finish, raise up your hand. I will call you, you tell us your X, Y, Z. That is where we are going. Six minutes to go.
Last one.
Yaushe ne na last one?
Hello, sir. Can you hear me, sir? Hello, sir.
Two minutes to go. We have two people already finished. Just hold on. Don't tell us your answer, please. Once the time up, then we can now check. So What is happening to us? Only 2 people after a minute left. Okay. Should I give us the grace of 2 minutes? Or we are nowhere to be found? So silence means no, we don't need it. Okay, stop writing, everyone. Stop writing. Okay. Deborah, what is your solution? What do you get?
X equals to y equals 5 and z equals 1.
I can't hear you.
X equals to y equals 5 and z equals 1.
Okay. Really one?
Yes, sir.
Your solution is what?
X is equals to 2, Y is equals to 5, and Z is equals to 1.
Okay, let's try it. Do we need to solve it, everyone? Anyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
But you did not talk when I asked you to solve it. If you know there is a noise background where you have, mute yourself. Garuba, Awao, please always mute yourself. So, okay, if you said we should solve it, let's try it together and see whether we are still using the same method. Let's pick up our matrix. So from the matrix, now I would like to say this. Some of us, yes, you can say, oh, do we really need this one? I just pity some of you, because why you need it is not because of the exam you want to write in December, it's because of the future. Remember the scenario I told you last time? For example, if I'm at the panel to interview any of you, and you told me you read computer or information technology, I know the question to ask you. And okay, maybe I'll tell you one of the things, one particular thing that happened to me personally. I will tell you the story after the class. Okay, let's continue, please. So at this point, do we all agree with this? I need a response. Do we agree with the matrices?
Yes, sir.
Okay,
Yes, sir.
remember your aim. Your aim is to make this place to be 0. That is a triangle. You need to make this particular lower triangle to be 0. So for us to do that, the first target is let's start with this. It's not compulsory you start with this. It all depends on you. But make life simple for yourself. So our R3 will be what? Anybody?
2R3.
You said?
2R3.
I don't understand 2R3.
2 multiplied by R3.
R3
minus.
again.
Yeah, we are making R3. We want to make that 0.
No.
2 multiplied by R3 minus.
It can't be R3, bro. Any other person, please?
Sir.
Yes.
R3 is equals to R3 minus 2R2, sir.
Do you understand now? The first professor. So because you are to solve R3, you can't multiply R3 again. You want to reduce it, you are now multiplying it.
It's okay, I got it.
You saw, can you see where you made the mistakes?
So I didn't even go that step. I tried to transform R2 and R1 so that I make sure that my R1 went up. R2
I've told you, you don't need to solve the diagonal first. Solve the lower triangle first.
Okay.
So that if you can make the 3 elements to be 0, then the road will be smooth for you.
Okay, sir.
Okay, let's continue. -1. This one will remain itself. This is 12. Next, 1, 3, 1, 18. Remember, our operation says 3R minus R. This is 3. The first element, 2 minus 2 times 1.
2.
2, which is 0. Put 0 here. Then the next one, -1 minus 6 minus 7.
7.
-7, not 7.
Yes, sir.
Then the next one will be -2 minus 2 equals to -4. Then the last one will be -3 minus 2 times 18.
-36.
36. Sir, 36. Okay.
-39.
Yeah, 36 minus 3. -3 minus 36.
It's 39.
-39. Don't forget the negative, because it will back on you. So we already achieved one. The next one is to do what? Which one is next?
Oh, 2.
2.
Yes,
okay,
sir.
what is happening in 2? The operation in 2 is what? R2 to what?
Sir,
Anybody, please?
so I think it will be easier if we switch row 2 and row 3, sir.
Row 2 and row 3.
Sorry, it is row 2 and row 1, sir.
Why?
Because we have unity. Because in our unity will be the leading coefficient, and it will make our operation to be easy.
Well, that's one form, but I can decide to leave it like that.
Okay, sir.
Okay, I can say that row 1, I can put it this way. I can say -4. Somebody should mute it, his or herself, please. The speaker is making noise from. I can say row 4, minus row 4 multiplied by row 2 plus row 1. Is it not possible?
It's possible, sir.
It's possible. So
very possible.
We can continue by saying row 1 will still remain itself.
4, 1, minus.
What will happen to row 2 now? So let's solve the row 2. Remember, row 3 will also remain itself.
Yes.
So row 2 will be -4 plus 4. 0. Put 0 here. Because you are adding it to row 1. So the next one will be -12 plus what?
Plus 1.
Plus 1 is what?
Minus 11.
So the next one will be 4 minus 4 minus what, please?
1.
1 minus 5. So the last one will be, don't forget the constant. -4 times 18.
72.
Anybody?
72.
Is what?
Minus 72.
Minus 72.
Minus 72
Minus
plus
50.
12 is equals to what?
Minus 60. Minus 60.
Minus 60. So in this case now, what do we need to do? The next thing is, remember, it still remains this particular gentleman to be 0. So what is R3 operation will be now? Anybody? I'm waiting.
R3 plus R 7 arrow.
Nobody. Deborah, what will happen? You must be able to think diverse way.
So what about if we multiply the coefficient?
Hello, sir.
Yes.
7R3 plus R2, sir.
Plus R2, there is nothing. 7 cannot make R3 to be 0. 7
Hello,
is
sir.
there. Yes, go ahead.
R3 will be R3 plus 7 over 11 R2, sir.
Hi.
Yes.
So,
It will give us 0, sir.
So R3,
yes.
I will use R3 is 11. Okay, 11 multiplied by R3 plus 7 multiplied by R2.
You are almost there. You got it, but you're almost there. Just sign. Remember that you have, I can put it this way. Let me scroll it up. I can just say 7R2 plus the negative 11R3.
Yes.
Do you agree? Because
Yes,
7 will multiply 11. It will give you 77. 11 will multiply 7. It will give you the same thing. So you cannot add them together with the negative. It will equal to 0. That is mathematics. It's just a simple arithmetic. So let's continue. In this case now, 1 will still remain itself. Then 2 will also remain itself. Now, for the R3 now, will be the one we work on. For R3 will be 7. Can we multiply it now? 0 is still 0. So R2 will be minus 77 plus, remember this is negative, minus 11 times minus this will be positive, right? Will be positive 77, which is equal to 0. Then 7 multiplied by minus 5, minus 35, right?
Minus 35, yes, sir.
Minus 35, though we have minus 11 multiplied by, will now be plus 44. What's the answer?
9.
9, thank you. So then 7 multiplied by 60, minus 60. Minus what?
420.
Minus 420 plus 11 multiplied by 39.
429.
The answer will be what?
429.
The answer will be 9.
Yes, sir.
Okay, so these are the, remember we've already achieved this. We don't have problem. Now, the middle one, which is our target now. That's why I said the first thing you need to resolve is to make the lower triangle 0. Once you successfully do that, the diagonal one is very simple to do. Let's look at how simple it is. You and I, we agree. It's just one operation. So how do you perform the operation on others now? How do you make all the diagonal elements to be 1? Let's think.
We divide by the coefficient, sir.
Yes, divide by the coefficient. That's all. So row 1 will be what?
1 over 4.
1 over 4, row 1. Can you see? Row 2 will be
1 over minus 11.
Minus 1 all
11.
over 11.
Minus 11.
Row 3 will be what?
1 over 9, row 3.
1 all over 9, row 3. That's all. So we can proceed from there. So it will be 1 over 4. Don't forget.
1 over 4.
Minus 1 over 4. Do you agree?
4. Yes, sir.
Then
3.
3. Some of us will just divide because of our target. You go. Or you are your own. No.
0.
No, this one will be what? 1.
1.
Minus, this will be
5 over 11.
5 over 11. And this will be what?
60 over 11.
The last one?
0, 0, 1. 1.
Do you all agree? So if you substitute this into your, don't forget, this is your X, Y, Z, and constant. If you substitute this one there, your equation will be X plus 1 all over 4Y minus 1 all over 4 z equals to 3. Then you have y plus 5 all over 11 z equals to 60 over 11. Then the last one will be z equals to 1. So you can solve it and you get your x, y, z. So those ones that did it, they got it right. If you did it very well, your s will be 2, your y will be 5, and your z will be 1. Any question? Any question, please? Any question?
Yes, sir. I have a question, sir.
Go ahead.
Sir, the only challenge I'm having is how to multiply the rows, how to dictate the right row to multiply. Is there any clue on how to get it, sir?
The only clue you have is a very simple way. Have it at the back of your mind. I need to lower you need to lower this. That's the first clue. How do I know? Now, assuming this is 10, this first element is 10. How do you make 10 to be 0? The only thing that can make 10 to be 0 all over the world is by taking 10 out of 10. Do you agree with me?
Yes, sir.
So, which one has 1 or 2? For example, let's say row 2 here, I'm just using an example, is 2. So it simply means, and row 3, row 2, I'm just giving an example, please. Don't scatter your book. And it's still 0. And here is 10. And I need to make this element. This is my target. Others will remain the same. I don't care what happened to them. But my target will be, I need to work on my target. It's like you are the wall. And you can see the enemy far away. And you have they give you the gun to target the enemy. How to eliminate enemy will be in your brain, right? Whether you bend when you are using your gun or you crawl, we are less concerned. Now, the first thing is, look at this. Let's say 2 is there, and I want to eliminate 10. I can decide that, okay, I can multiply this one. 6 is 10. I can say R1, I can say 10 multiplied by R1. Then minus R3. Do you agree with me? Because 10 times minus, you cannot say 2R3 because R3 is 10 and you want R3, you cannot reduce R1 because you want to eliminate R2, R3. R1 is on its own. So if I said 10 multiplied by R1, which is 20, minus, I cannot make this one also to be 20 in order to be able to eliminate it. It's just a simple arithmetic. 2 times 10 become 20 again. You understand? You have your 0. You already have your target. It doesn't change R1, neither it's only R3 that you are working on that will change. Have I answered your question, please?
Yes, sir. Thank you, sir.
Okay, Francis.
Sir, like when you started, you said that you cannot multiply R3 with any number because it will increase it. Like instead, you look for a number that can eliminate it to make it 0. But my question is this: You actually did R2 when you wanted to change R2 to 0, you actually multiplied it by -4. So what I'm trying to say is that method not still applicable to that R2?
Don't make
Because you
mistake. Don't make mistake. It all depends on the kind of element you are dealing with. At that particular question, that's why I said I don't want to do that. Not that you cannot. I was just trying to explain that since I have alternative, in this case that I just explained to the last person now, remember this is 0. Anything multiplied by 0 is what?
0.
0. So now, why can't I make 1 to be the same thing as 10? Or make 10 to be the same thing? Because you cannot say 1 plus 9. Or have you seen any operation that says R1 plus 9?
No, sir.
Aha. Is either you use multiplication or division most times.
Okay, sir.
I hope I'm clear. So any other person, somebody else, raise up your hand. Okay, I've answered all. Okay.
Hello, sir.
Yes.
Yeah, like in the case of when we were using the reciprocal of those coefficients to divide it, why not, if I'm in this last stage that I have 9 and I'll say my z is 9, z9 is equals to 9, then I'll say divide both sides by 9 and I'll get my, instead of going back and be dividing it again by their coefficient, by their inverse.
Okay. Now, the question, the law says, get this done. And the same law says 2 things you have to do. First, reduce the lower matrix to be, lower triangle matrix to be 0. And the second law says, make diagonal to be 1. Is the law we are following. Not that we want to do it anyhow. You can see that's why I said the one that is a bit tricky is by, first of all, find a way to make this gentleman to be zeros. Then work on this. This one you can see is very simple.
Yes.
That is why we need to do this one too. It's part of the law for the Gaussian elimination method or backward substitution.
Noted.
Okay. Any other question? So if I give you a question now, you will solve it within 5 minutes. Yes, somebody raise up their hand.
Sir, please, you said we should first of all look at the row 3, column 1. We should first change it to 0.
I'm not saying you should first. It depends on the question. For this particular question and this method, you must first of all lower. It depends. You can start with row 2. Look at the method Tayo used the other time to solve their own is different from the method that I use now. And we got the same answer. Because what they did, they just interchanged. I will mark it for you. I will surely mark it because there are different ways to kill the chicken, like we used to say. Some can cut it from head, some can cut it from. There are different ways. That is why mathematics is a bit unique. So you can decide to, okay, row 2 is convenient for me. Anyone you start with will surely give you the same this. Have I answered that?
Yes, sir. Thank you.
You're welcome. So, any other question? Yes, any other question? Balogun Said.
No, sir.
This is your first time in my class, right?
Yeah, sir.
You said?
Yes, sir.
So we'll be looking at the row, reduced row echelon form. So which means for reduced row echelon form, there are many things that are involved. It's still the same row, the way we reduce everything we have been reducing. But the only thing different is we have what we call pivot position. And what is pivot position? Let me write. We have reduce row echelon form. Call it RREF. So one of the things we need to take notes is the same thing we have, the same idea that we had from echelon, row echelon form. One of the properties there for row echelon form, it says all non-zero rows are above any row of all zero, of all zeros. Don't forget. Number two, it says each leading entry of a row is in a column to the right of the leading entry of the row above it. Then number three says all entry in a column below a leading entry are zeros. Remember, we are still talking about the lower triangular matrix being zero. Then in this case now, in addition, we said the leading entry in each non-zero row is 1. Don't forget, the leading entry in each non-zero row is 1. That is, each leading one is the only non-zero entry in its column. That is, each leading one is the only non-zero entry in its column. So for us to, what we are saying is, in this case, let me just give us an example. Look at this. If you have this 2 minus 3, 2, 1, 0, 1, minus 4, 8. You have 0. Sorry. So when you have this, and the other one says I'm just giving us the kind of matrix we are talking about. I'm not solving anything here. So this one will 0, 1, 0, 16. This one is 0, 0, 1, 4. Let's just assume. So this particular one is row echelon form, while this one is reduced row echelon form. Remember, the leading entry in each non-zero row is 1, as you can see here. Other elements below, they are what? Zeros. While the upper one are non-zero, only non-zero row you have seen have the other entry. So please, let's take note of this and let's look at it. Now, how do we solve this? There are theorems that are, a theorem is just like a result, says theorem, so each matrix is row equivalent to 1 to 1, and only one reduce echelon, only one reduced echelon and matrix. So now let's look at it. At this point, it will now lead us to pivot position. Idris was asking us last time if I pivot position. So the pivot position says a pivot position, underline it, in a matrix A is a location in A that correspond to a leading one. In the reduced echelon. In a reduced echelon form of A. So I will use the maths to explain so that you will understand better. Then a pivot column is a column of A that contains a pivot position. So let's take note of that. Now, let's solve the question. Let's look at the example. Example 1 says, write the echelon form and then the echelon form of the following matrix. Write the echelon form, we should write the form of the following matrix. We have to write the 2. Okay, the matrix says excuse me. So for this matrix, we have A to be equals to 0, 3, minus 6, 6, 4, minus 5. Another one says 3, minus 7, 8, minus 5, 8, 9. The last one says 3, minus 9, 12, minus 9, 6, 1, 5. So what is the dimension of this matrix? Anybody?
Three by 6.
3 by 6.
3 by 6.
Yes, sir.
Good. Why? Because we have 6 columns and 3 rows. So what is pivot now in this case? How do we know pivot column? Which one is pivot column? Anybody?
-5, sir.
I only need column. I don't need the elements there.
Okay. Pivot column.
Read the definition before you answer, please. Nobody. Let's continue.
Zero, sir.
Which one is 0?
Column 1.
Column 1. Why? You are right, but I want to know the reason.
One corresponding to leading one.
Is one corresponding to leading one, right?
Yes, sir.
How?
Because is the A matrix, because it's 0 leading one with 1.
Okay. Anyway, you might be right, but I don't know the reason. But you will see, tell us as time goes on. You will all see. Anyway, we can identify that this is our pilot column, pivot column. Okay, let's continue. But how do we solve this problem? For us to solve this problem, we know that first row first column rather must not start with 0. Do we agree?
Yes, sir.
So what do we do?
We interchange it with row 2 or row 3.
Good. We interchange it. We can say row 3 interchange to be row 1. Our row 1 equals to this now. So let's interchange. We have 3 minus 9, 12 minus 9,
6,
15.
3 minus.
Let's write this one. 0, 3 minus 6, 6, 4 minus 5. Then the middle one, 3 minus 7, 8 minus 5, 8, 9. That's the first thing. Now, the second thing is, how do we reduce? What do we do again?
Now,
let's start. We know that the entry point of row 3 is 0 already. The entry point of row 2 also must equal to 0. Do you agree?
Yes, sir.
So our row 2 will now be what?
Row 2 is row 2 minus row 1.
Why the other way?
Sir, to make it 0.
Remember the road you are dealing with. We are not going to attack it. If you say row 1 minus row 2, what will happen?
No. It will still give us 0.
It will still give us.
Yes, sir. Yes, sir, it's the same thing.
It's the same thing, sir.
To you, it's the same thing. It's not the same thing in all cases.
Oh.
Do you agree with me?
Yes, sir.
Yes, sir.
Based on the sign.
Aha. Because of the sign. So now you have to be careful so that you won't put yourself in trouble. So here we have what? 3 minus 9, 12,
minus
9, 6,
15. 0 minus 15.
So our row 3 will still be the same.
Yes.
Let me write that one. 0, 3 minus 6, 6, 4 minus 5. So row 1 minus row 2, 3 minus 3.
0.
Minus 9 minus 7.
Okay.
Right?
Minus 9.
Yes, yes.
Minus to right.
Minus.
Yes, sir.
The next one is what?
12 minus 8.
Now, the next one minus 9 plus 5.
Minus 4.
Minus 2 and 6. Any question? So what do we do to row? The next thing we need to reduce is what?
Row 3.
Row 1.
No, row 3.
I've told you, anything in diagonal, don't trouble yourself first on diagonal.
Row 3.
Work on the way to reduce first. We need to reduce row 3. Yes. So how do we reduce row 3?
Okay.
Minus 2 row 2. Okay, minus, okay, 3.
Minus 3.
3 row 2 minus 2 row 3.
Look at it very well.
3
sir.
row 2
Hello, sir.
plus minus 2 row 2.
Hello, sir.
Yes, Akim.
Sir, row 3 will be 3 row 3 minus row 1.
Let me give you an hint. The next element in row 2, which is minus 2, must be equals to 1. Take note of that when you are dealing. So what next? Why can't we make that one along the line? Who can suggest? I'm waiting for us, or should I leave it for us to go and solve?
Sir.
Yes.
I think row 3 will be 2 row 3 plus 3 row 2, sir.
2 row 3?
Yes, plus 3 row 2, sir.
Okay, maybe I should help us. Let's deal with row 2
minus
first.
Sign there.
Let's deal with row 2 first, all of us.
Okay, we can divide both sides. We can divide it by 2. Okay. Okay, should we reduce row 2?
It depends on you. The ball is in your court.
So let's reduce it by minus 2.
By the reciprocal, 1 all over minus 2.
Yes, you are making sense now. Which of them?
Row 2.
For row 2.
Row 2 is what?
We reduce it by its reciprocal, 1 all over minus 2.
Okay. You can see 2 goes in all.
Yes, sir.
So would that say row 2 tends to minus 1 all over 2? Row 2, right?
Yes, sir.
Do we all agree? So
Yes,
we
sir.
have 3 minus 9, 12 minus 9, 6, 15. So here we have 0.
1.
Here you have 1.
Minus 2.
Minus what?
2. Minus
Next.
2. Then 2.
Minus 2.
1.
2.
Minus
1.
3.
Minus 3. So here we have 0, 3, minus 6, 6, 4, minus 5. I think we can reduce 3 too. Do you agree with me?
We'll have a fraction.
Yes, it doesn't matter. It's still part. Are we not using fraction to work on them?
Okay. We can reduce it 1 over 3.
1 all over 3.
3, yes, sir.
R3. So I'm going to clean this place. I'll just do it once. Is that okay?
So, and the same 1 over 3 can be applicable in row 1 too.
Sure. Okay.
So why not we do it simultaneously?
Okay. Row 1. I hope it will not. You guys will get what we are doing. 1 all over 3, row 1. So, okay, let me do it this way so that people will not be confused. Let's just finish the one of 2. Is that okay?
Okay, sir.
So let's finish the one of 2, then we'll do the 1 and 3 at the same time. So the next operation is just to make life easy for ourselves. It is easier to deal with 1, 2, 3 than you are dealing with. Row 1 will be 1 all over 3. Excuse me. Row 1. Then row 3 will be 1 all over 3, row 3. So we can go ahead by saying 1. This is minus 2, right? Minus 3, rather.
Minus 3. 4.
This is 4.
Minus 3.
Minus 3.
2.
2.
5.
5.
So here is 0, 1.
1.
Minus 2.
Minus 2.
2. 1.
1.
Minus
3.
Minus 3.
Minus 3. Here 0.
0. 1.
1.
Minus 2.
Minus 2.
Minus 2. 2.
2.
4 over 3.
4 over 3.
Minus
5 over 3. Now, let me quickly hint us so that you won't be confused. Look at this. Assuming our leading here is minus 3, remember you multiply it by minus 1 over 3. Do we agree?
Yes, sir.
Hello, sir. Come again, sir. I can't hear that, sir.
Now, assuming this element here is minus 3, remember we are going to multiply it with minus 1 over 3. Do you agree?
Yes. Oh, yes, yes, sir. You have to make it zeros. I want, sir.
Yes.
Positive.
Yes. Yes.
So the next thing is, which one do we need to reduce now?
R3.
Yes, correct. Then what is our R3 will be? Operation will be?
R3 minus R2.
R3
minus R2.
Minus R2, correct. So it's going to be 1 minus 3, 4 minus 3, 2, 5. Then 0, 1 minus 2 minus 2, 1 minus 3. Then this one will be 0 minus 0.
0.
0. 1 minus 1, 0.
0.
Minus 2.
No, sir.
Yes.
There's one issue. Okay, you've changed it.
Are you okay with it?
Yes, I observed I've changed it now.
Okay, thank you. Minus 2. You have to be careful here. Minus
2.
Another minus 2 is what? 0.
0.
2 minus 2, 0.
0.
So you have 4 over 3 minus 1. What's the answer?
1 over 3.
1 over 3. Thank you. So this one will give us what? 4 over 3. Any question, please? So which one again do we need to reduce?
Row 3, sir.
Row
3.
Row 3.
We just finished row 3 now. Or do we need to reduce it more?
Yes, sir.
So by what?
We multiply by 3.
multiply by 3.
By 3.
R3 is equals to 3 R3.
So it's going to be R3 tends to what?
3
3R3. Do we agree?
Yes, sir.
So the answer will be 1 minus 3, 4 minus 3, 2, 5. So we have it to be 0, 1 minus 2, 2, 1 minus 3. Next, 0, 0, 0, 0. This is will be what? 1. This one will be what?
4.
0, 0, 1, 4.
Any question? Are we making sense now?
Yes, sir.
Yes, sir.
Yes, sir.
So what else do we think we can do?
Nothing, sir.
Really?
Yes, sir.
We've not make the diagonal elements one. We need to make the diagonal elements one, sir.
Yeah.
That's another thing. But we are there. Only that we need to also work on row 2 and row 1.
Yes.
Let's look at row 2 and row 1. What do you think we can do? What can we do to row 2? I'm waiting for us, please. We are almost there. Anybody?
So,
yes.
I don't understand what you are saying. Are you saying that we should also make the remaining elements 0 in row 2 or what?
No. But you can see that by the time, most times, we want to reduce it to barest minimum at this point. But anything you are doing must not change that diagonal element. You must be careful. Do you agree if I say, let me just put something there, I will see whether you agree or not. Do you agree that my row 1 can be 3 row 2 plus R1? And R2 minus R3. Let's check it. What do you think they will give us? I'm waiting for us. What do you think it will give us?
Sir, it will eliminate the entries of A 1, 2, sir.
Which of them?
-3. It will eliminate -3, sir.
Okay, it will eliminate -3, 1. What again?
For row 2, sir, it will eliminate. Sir, let me
It
check,
will
sir.
also reduce 4 to 2, as in for the row 1. 4 will be reduced to 2.
Which of them?
For row 1,
yes.
4 will be reduced to 2.
Yes, you are right. So let's try it first. So it's going to be, for row 1 now, row 3 will be the same thing, right? Let's start from row 3. Row 2 will still remain its identity, right?
No, sir.
Yes.
So I think we have formula for row 2, sir. So I think it will change.
No, we don't want to, don't do the two operations at the same time. I'm only giving us this. You understand? Don't do two operations at the same time. Let's finish one first. It's for your own good. As for me, I don't have a problem with that. But people will ask you questions now. So now, let's solve the question now. Are you getting my idea now?
Yes, sir.
So what's going to happen to it for row 1?
We have 1, row 1, 1.
What the next one is what?
0.
0.
2.
2.
3.
Is it 2 or minus 2?
Minus 2.
Minus
2. Oh yeah. The next one is what?
3 brackets.
3. The next one? You don't get it.
5.
5. Thank you.
5.
The last one?
minus 4. Minus 4.
Minus 4.
Minus 4. Now.
Sir.
Yes.
1. 0.
No, for column 3, sir, the 2 is supposed to be minus 2, sir.
For column 3.
Column 3, sir. Yes, sir.
You're right. Now that you have this, what else do you think we can do? Let's look at it together critically before you can say, yes, you are done.
I think our R1 can still be R1 minus R2, sir.
R1 minus R2.
Yes, sir.
If it is R1 minus R2, what will happen?
The column 3, the minus 2 will be eliminated, sir.
But always remember, now our if you read the definition, our leading entry is 1, and the remaining elements, they are 0 here.
Yes.
Are you getting it?
Yes.
Get the idea clear. The leading element is 1. The remaining element in that column, let's go to that. Let's go to it. That for the reduced, I'm still coming back. Let's look at it. Each leading entry, non-zero row is 1, which we already achieved. Each leading 1 is the only non-zero entry in its column. That is for each leading 1 is the only non-zero. Non-zero means it's not equal to 0. Entry in its own column. Now, let's go to that part, the last one. So look at row 3. The leading element here, which is 1, what happened to other 2?
They are 0.
They are not 0 here. They suppose this is the leading, according to the definition.
Yes.
The remaining one must be what?
Must be 0.
Must be 0. So that is your target. But the leading one will be 1, others will be 0. How do you make 5 and 4, 5 and 1 to be 0? That is the next thing you need to do. Excuse me. For us to do that, it's very simple. You have different skills to do it now.
R1 minus 1, R1 minus R1. R2 minus R2.
So let me clean this so that you, okay. So what do we do?
Sir.
Go ahead.
We can say R1 is equal to R1 minus R1 to make 5, 0.
Sarah, please be careful. You are writing something on your system which is affecting our own sharing.
And R2, we go the same way for R2 to make 5 and 1, 0, sir.
How do you make 5 and 1, 0?
Okay. First row, R1 is equal to R1 minus R1.
No, it's not possible. R1 cannot say minus R1. Why can't you say 5R3 minus R1? Or we can say R1 minus 5R3. Is it okay by you?
5R3.
Yes, sir.
Okay, it's okay.
We can say
yes.
R1 minus 5 minus 5 R3. So then for R2, let me try and do the two together now. I believe the elements are simple now.
Yes,
for R2 will be what?
R2
minus R3, right?
Yes, sir.
So it's going to be 1, 0,
1 by 1.
Minus 2, is it going to be like that?
Yes, sir.
The next element is what? Our target element will be?
That is 0.
0.
Yes,
minus what?
Minus 4. Minus 24.
Minus 24, thank you. R2 will now be what? 0.
1.
1 minus 2. 2. 0. Minus 7. Do you agree?
Yes, sir.
0, 0, 0, 0, 1, 1. So this is what we call a reduced row echelon form, because this is what we call a reduced we already know these are the leading row, which is 1. And the other element in that column that belongs to them, they are 0. Please take note of that condition.
So I
Hello,
just
sir.
get what you're trying
Hello,
to
sir.
say, sir.
Yes.
Hello, sir. So it means it does not matter if in this kind of row reduced row echelon form, it does not matter if all the diagonal element is 1, as long as we can. If the first leading row, the element after the first leading row is 0, which is applicable to others. So it does not matter if all the diagonal element is 1, sir. In this case of RREF.
I did not get what you are trying to say.
What we've been doing.
The diagonal elements, right?
Yes.
Look at it. It is difficult most times to get the diagonal element here because the row are not equals to column.
All right.
But that is why they are using the leading entry point. If I want to get the diagonal now, how many things will it cause across? What happened to this young man?
In fact,
although the last one here is always the constant of the variables that we are working on. This one is always a constant because they can ask us to write the equation out of it. It is possible. For example, how many elements do we have? I can say S1, S2, S3, S4, S5. I can say it. I can call this one S1, S2, S3, X4, X5. Why this is constant? If I want to write the equation out now, just look at me. The others are free. Anywhere you see 0, they are free variables. We call them free variables. Because now, from here now, 1 times x1 is x1 plus free variable 0 minus 2s2, s3 rather, plus 3x4 plus 0, which is free variable, equals to minus 24. Then the next one is 0. I'm not supposed to write it because I'm explaining. That's why I'm writing it for you. S2 minus 2s3 plus 2x4 0 plus 0 equals to minus 7. So these are 0 plus 0 plus 0 plus 0 plus x what? S5.
X5
equals to 4. So on the normal day, if I want to write it out now, it's easy for me. I can just say x1 minus 2s3. I will leave the, you can leave, you just do as if you are leaving the 0. But I can write everything together. It doesn't make any difference. I can just put it this way, plus what? Okay, minus here.
Minus 2x3.
Minus 2s3
plus 3x4
plus 3x4 equals to minus 24. So we have S2 minus 2s2 s3 plus 2s4 equals to minus 7. This is S5 equals to 4. That's all. If they ask you to write the equation out of it. Thank you. I believe we grab one or two things.
Yes, sir.
Let me stop sharing.
Yes, sir.
Hello, question, sir.
Okay, go ahead.
Sir, I also want to appeal, sir. If at the end of this lecture, this particular video too can be released so that we study towards our exam.
Students, is there any other video that I've not released?
Okay. I'm only making.
No
one, sir. No, actually.
So there's no other video that I've not released. I always release all the video to you guys.
All right.
So it's for your own good. And when you have access to video, it will help you to study more.
Yes.
So that's just it.
Thank you, sir.
Yes, sir.
Okay.
The issue of this free variable, those zero, what is the application?
It all depends. For example, some of us in engineering, I just want to create a scenario. Okay, some of us in chemistry, let me use chemistry now. In chemistry, there's something we call free radicals. And they move from one point to the other, they move from one point to the, or free electrons. The way we normally use it in engineering. Do you get it now? So, for example, if you have the free variables, some people will tell you, some video will tell you, oh, free variable, you can use it to fix anything, you can do it, you can put it here, you can continue using it, you can substitute it here. It all depends on the application you are working with. The area you are working with, if you have access to engineering mathematics, you can make use of it. You will see where they put it there. The application aspect of it. It's applicable. If you are in the medicine now, if you want to use it, it depends on the field. That's where I'm going. The field you are using it will determine what you define your free variables to be. I don't know whether I've answered your question.
When we call it free variable, I think that later on there's the way we can make use of it in this mathematics we are dealing with.
Well, as time goes on, let's wait and see.
Okay. Thank you.
You're welcome. Regina, any question? Yes, go ahead.
Lost on the way. I lost on the way.
You lost on the way. Don't worry. Video will find you. I will try as much as possible to release the video today.
Okay, sir. Thank you,
so
sir.
That the time will not be too long for you guys to have access to it. I believe that one is okay. Yes, Said.
Hello, sir. Where can I get the video?
That means you can see you're a stranger in your house. Just imagine, which department are you?
Computer science.
Computer science, and you are coming after 9 weeks. Today is 9 weeks for us here. Am I right? Some of us that we started together. Anyway, if you check my YouTube page, you will see it there. If you check your course page, it's there too.
Okay.
I always do that. And majority of you don't visit the course page. I don't know why. Anyway, as from next semester, it won't be as usual. I think the management are working on that so that you guys will be able to access, to be able to, So if the leading element must be 1, it simply means, let's look at it. The question says, the first question says is 0. We have 0, right? And at the point where we have 0, what do we need to do? I know that my diagonal matrix must not be, it cannot start from 0. It will start from 1 or with element. So I have first of all, interchange the matrix. Anyone that have good elements or have elements in their own row, I will interchange. It might be 3, it might be row 3, it might be row 2, it might be row 4. It depends on the number of rows. Anyone that you think is convenient for you, just interchange. After the you finish interchange. Now, how do I make that element to be 1? Will be my target.
Okay.
So I reduce it to be 1. Now, if you check the final answer, you discover that each of the row has the leading element. The first row, which is row 1, has 1. That is the first element there, which is leading element.
Yes,
and all other in that column, they are 0.
0. Yes.
The second row, the leading element move to the second column, right?
Yes, sir.
You see, all the elements in that column also must be 1. After the leading element is 1.
Yes. They are all 0. After the
They are all
element.
0. So the last one, you see, we have another one. All the elements in that column will also be 0. Anywhere you have the leading element, the column, the other element in that column will be 0. That is what is called row reduced echelon form. That is just a simple analysis to a layman language. Like
okay,
us.
thank you very much, sir.
Any question? Joshua?
Yeah, you have I've now assimilated it.
I can't hear you.
I said I've now understood what you're saying.
Okay, you are welcome.
Thank you, sir.
Baba Adebisi, any question?
No, sir, thank you very much. I think you find time to take all this part. I appreciate it. And again, I look at the one you posted on our WhatsApp group. I've looked at it, and it's very simple and straight. So I've checked all of the one. It's very nice. So I think I'm confident now. It's not like the last semester that we don't have lecturer for this for the mathematics for this time, and I'm just confident that yes, I think I'm the right partner.
Okay, how many of us have done our TMA1?
Yes, I did my own.
I've done my own, sir.
Did you got 10-10?
Oh, I got 9/10.
Okay, that's good. That's good. At least you are confident. That's interesting. Who again?
I got 10.
You got 10? Francis of all people. Clap for yourself. That's interesting.
Thank you, sir.
Who again? Joshua.
Yes, sir.
What is you got? What?
I got 10.
Oh, that's great. I'm happy for you guys.